This is lesson 7.3a, elementary algebra, addition and subtraction of rational expressions. Now, one of the things that you're probably finding out pretty quick in this class is that it not only moves along pretty fast, but it gets more and more challenging really fast. So we're going to look at some fractions here. If I wanted to add 2/3 plus 1/3, what do I do? What do I do when I add fractions? I add the numerators and leave the denominator alone. But the key thing is the denominators have to be the same in order for me to add fractions. Well, the same is true when I have things like example 1. I cannot add these unless my denominators are the same. Alright, so when they are, I just take my numerators and add them and put them over the denominator and get 8 over x. Alright, when I have one like example 2 where I have x over x squared minus 9 plus 3 over x squared minus 9, I add these together. Okay, but before I'm done, I look and see if anything can be simplified. Well, x squared minus 9 is the difference of two squares, so those can be simplified to that. I can cancel that with that, and again, I have nothing up there, so I have an assumed 1 up there, and I get an answer that looks like that. Alright, let's jump to example number 3. Okay, so notice my denominators are the same, but there might be a way for me to cancel some things. So I want to change my denominators to two binomials if I can. You can't always do that, but I think in these lessons they're going to make it so that that can be done. So this is x, 3, 1. 3 times 1 is 3. Negative 3 and positive 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is a negative 2. So we're going to get this in both of these since that and that are the same. Alright, so I'm looking here to see if there's anything I can cancel. And there doesn't seem to be, so I'm just going to put my denominator, my numerators together. 6x minus 13 minus, remember to put that in parentheses because this minus is being applied to this whole thing, not just the 2x, over x minus 3 times x plus 1. Okay, now I can go ahead and combine like terms there. 6x minus 13, take the parentheses off, change the sign of everything there. And again, I'm still simplifying, x plus 1. And I get 6x minus 2x minus 12. And then here I can factor out a 4. That cancels with that, and I'm left with 4 over x plus 1. Okay, so the key thing when you're doing these, not only do you need a common denominator, but you need the top and bottom simplified as much as possible because of the good possibility of being able to cancel. And that's what we did there. Alright, in this next example, we're going to make another change, and this change is a rather big one, because we're going to look at some of these fractions or rational expressions when the denominator is not the same. So, for example, what if I want to add something like that? I can't just add a negative 3 here and a negative 3 here. That doesn't work. Alright, so I do it You know, and you've heard me say this before over and over and over. I do it differently than the book does, but after 20-some years of doing this, you know, the book does it in a fine way, but I'm going to show you a different way and see if we can make it so it's a little bit more doable for you. So this is example 5, and the instructions say to find the least common denominator. Well, we're going to find the least common denominator, but we're also going to add them. So we're going to go a little bit further. So the first thing that we do is we simplify everything that can be simplified. Well, the x minus 5 and the 3x, those are as simple as we can go. But notice my denominators are different. Well, I'm going to simplify my denominators and then find common denominators. So let's look at this first denominator. We'll leave our numerator the same. What's common to all those is a 2. Okay, and then we'll write this numerator the same, 2. That'll break down into 2 binomials, a 1 and a 1 and a negative and a negative. Because negative 1 times negative 1 is positive 1, negative 1 plus negative 1 is negative 2. So this is this simplified. Alright, let's do this one over here in yellow. Factor out of 2. This is a difference of 2 squares. So we have 3x over . Okay. So I want to warn you, I copied this problem down incorrectly, so things are going to be a little bit different than the book, but the method is the same. Now what I do, once my bottom is simplified, so that is simplified and that is simplified, I look at all of the parts and I see if I am missing anything on either side, in either denominator. So, for example, I look here, I say, well, I have a 2 here. Do I have one there? Yes, I do. So that's good. That's common. I have an x minus 1 here. Do I have one over here? Yep, I do. I have one there. I have an x minus 1 here. Do I have a second one over here? No, I do not. So I need one. So what I do is I just put one on here. Oops. I just put an x minus 1 here, and if I did it to the top, I have to do it to the bottom. Then I'm looking at, okay, so I have one of these, one of these, one of these. Now I look at this one and see if there's anything here that I'm missing. Obviously I have my 2, I have my x minus, but I have an x plus 1 here. I don't have any x plus 1s here, so I do the same thing. Put an x plus 1 there, and an x plus 1 on the bottom. Now let's look and see what I've got. I've got a 2, x minus 1, x minus 1, x plus 1. Okay, now I have common denominators. And in order to add these, then I have to combine all of these here, which we'll get to later. But right now, let's just look at these common. That's how you find the common denominator. So what I want to do is I want to look at another one or two of just finding the common denominators so you see really how easy it is to find those. They're not really too bad. Okay, so this is number 24 in the problem set. All we're looking at is finding common denominators. Okay, so let's see what we can do here. First of all, we're going to simplify. I'm going to leave the top alone. That's as simplified as it can go. And we're going to factor out a 3x squared, left with an x minus 4. Over here, that's simplified. Can't do anything to that. But the bottom, we can factor into, let's see, 4 times 4 is 16. Negative 4 plus negative 4 is negative 8. So negative 4 times negative 4 is positive 16. Okay, so I'm simplified. That's what I need to do first. Denominator simplified. Then I go back and see what I'm missing. So I have a 3x squared here. Do I have one over here? No. So I put one on the top. And it's always good to just put them in the parentheses just so you have them that way. Now I have one on the second part. Now I look and say, do I have an x minus 4 here? Yes, I do. That's good. So everything here is over here. Now I have to look and see, is everything here over here? 3x squared, obviously. X minus 4, obviously. X minus 4 here. Do I have a second one? No. So I put 1 there. Now I have a common denominator. Okay? That's all there is to that. Find common denominators. You just simplify, find what's missing, put them on both sides, remembering to put them both on the top and the bottom, and then we'll go from there. So that's finding the common denominator. Now let's go and add and subtract these guys. All right, so what I'm going to do is I'm going to look at example number 6. And we're going to look at one with just numbers, and we'll do one with letters and numbers here shortly. I know you're excited. All right, so what did we say? You simplify the denominator. So we're going to make that 5 times 2, 7 times 2. Okay, now I'm going to look and say, all right, what do I have here that I don't have here? I've got a 5 there. I don't have one there, so I'm going to put a 5 there and a 5 there. Okay, so now I have a 5 and a 2. Now I look over here. Do I have everything here over here? No, I'm missing a 7. Okay, so 7 times 1 over plus 3 times 5. Common denominators, right? So I can add these. And I might as well multiply my 7 times 2 times 5 and get 70. And then I can reduce that to 11 over 35. So let's do the same thing for example 7. Okay, we're going to subtract here, which doesn't really matter. Everything's done the exact same way. So we simplify the denominator. In this case, they're both simplified. We can't reduce this x or this 2. So now I look at the x and say, is there anything missing here that I have over there? Yes. Is there anything here that I have here? Yes. So now my denominators are 2x, right? Okay, so I take my top number, 2 times 3 is 6 over 2x, minus 1x, or x, over 2x. Now I take 6 minus x, which I can't do. I can't combine a number and a letter, so I just leave it as 6 minus x over 2x. And key thing is you cannot cancel that and that, because that 6 is chained to that x with a negative sign or with a minus sign. Whenever there's a minus or a plus between things, you can't split them up. They have to be stuck together there. All right, let's jump to example 8. And we will start example 8 on the next video.